what I want to present is, of course, the vertical bifacial technology we already discussed by Next to Sun. Tobias already had some nice pictures from some of our plants. I think the technology is quite different from what we saw on the other pictures. Especially it's the vertical mounting we see here. And I think the advantage from the agricultural perspective is quite obvious. Yeah, we see that we have a lot of space in between the rows for agricultural use. We really are able to use heavy machinery. In this case, it's I think 260 horsepower tractor from Claas, which was working in between. Thanks to GPS steering, it was also it's also possible to use more or less, or let's say more than 90% of the ground in between. Yeah, since we only need very little space on the sides. What we also see here, I think, is that the topics Tobias addressed, we have nearly no, or we have no issues with dripping water from the panels down to the crops, since they are in between. Yeah, we have a very little superstructure, less than 1%, and only directly below this superstructure we would have this dripping water. We would not have any issues with water falling on the crops we wanted to harvest there. And indeed, another aspect Tobias also addressed is that we have, of course, maximize self-cleaning from the module, since simply it's vertical. Yeah, all the water runs down at the module whenever it rains and cleans the modules. We have no data from India so far. In Europe, we didn't do any cleaning of the modules, which is, of course, an advantage. We need to see how this works in India. Yeah. So this is not again a short overview over the structure. Yeah, we have the panel rows. We have just seen. This is a look. We are looking here on a plant from south, where we have this east-west orientation, which make a lot of sense. We will see that in later charts. We have these parallel solar panel rows with the frame, which is rammed into the ground, and in the middle, all the space left for agricultural management. The size between the rows can be, with this system we saw there with 2 panel rows, it makes a lot of sense to be around 10 to 12 meters. And what we see is, let's say, from 10, if we have a row spacing of 10 meters, we can use around 9 meters for agricultural purposes. And the rest can be used for establishing flower stripes or old grass stripes or things like that. Also for ecological enhancement purposes, which indeed is also quite favorable. That's some aspects maybe we sometimes already presented at different points, and today I would like to focus on the energy perspective. Here one of our plants where we see, this is from Germany. We see this is 4 megawatts plant, around 14 hectares. In this case, it's the grassland use. And we see that this is also possible and even economically possible in large scale. What is interesting, especially on this on the question regarding the grid integration, I think, is that on the one hand, vertical PV is quite flexible. The difference, if we mount it with east-west orientation or let's say south-north, the difference in production is quite low. Yeah, of course, it depends on the backside efficiency of the modules, but there is some optimum which is more oriented to east-west, but even south orientation vertical, depending on the location, but does not perform much worse. Yeah, so there are several degrees of freedom to also, on the one hand, build an interesting production profile, since the production profile over the day differs very much regarding the orientation. And on the other hand, we of course can adapt to the agricultural use. Yeah, this is of course for the double use also quite important to have the possibility to follow, let's say, how the landscape is oriented and how it could be used for agricultural purposes. What I think is also quite interesting, especially regarding the grid integration, and is of course the production profile. Yeah, and what we see here is a comparison of a conventional south-oriented plant compared with a vertical east-west orientation, and I think the result is quite interesting. It's more or less complementary. Yeah? What we see, we have a very early in the morning, we already have a strong PV production, and also in the later evening, and with only very low, it's around 25% of the production at noon, simply due to indirect irrigation. And for Germany, this is also very interesting, since it also is correlating with prices we see on the electricity market. In Germany, we already have negative prices at noon quite often in summertime due to a huge amount of conventional PV in the grid. And we see higher prices in the morning and evening hours. And this is, of course, also, on the one hand, the price is, of course, simply an indicator for the need of electricity. And we see that this is electricity produced in the morning and evening hours is more favorable than the one at noon. And on the other hand, of course, it's also an economic aspect, which helps us to realize such plants, since we simply earn higher prices with this production profile. On the other hand, the south orientation is also not that uninteresting, since there, of course, we have a production profile which is nearer to the one we see from conventional plants. But what we see is a shift from the summertime to the winter times. Yeah, so vertical PV already, of course, also dependent from where we install it, but this is, I think, also for some place in Germany. We see that we shift production from the summertime to the winter time, when the sun is quite low, and we have much better production and much better performance compared to a conventional plant, while in summertime the production of the conventional plant is higher. Yeah, and this might also be interesting, simply to have some shifting of PV production into times where the PV production is not that high today. So this is maybe an also quite interesting aspect about vertical PV and grid integration. And the third point I wanted to show is, of course, the combination of both, which also makes a lot of sense. On the one hand, with a conventional, or simply of different orientations of vertical plants. Since then, we can combine both, and especially get along with lower infrastructure compared to what we need for let's say it's vertical with one orientation or a conventional on a standalone basis. Yeah? So in this point, we've, for example, here some combination of a vertical east-west and a conventional plant. In this example with, let's say, a 63 megawatts transformer, which would normally work for around 80 megawatts of south-oriented PV or also only east-west oriented vertical PV. But if we take a combination of both, we can use this transformer for more than 100 megawatt, since we have we spread the production over the day, and we can use the capacity and the infrastructure simply more efficient, which is also, I think, quite interesting possibility this type of installation offers. Yeah, that was a short overview over these aspects. I'm quite happy if we can discuss topics you're interested in, and thank for your attention.